A patient needs an IV infusion of dopamine at a rate of 4 micrograms per kilogram per minute. The patient's weight is 70 kilograms. The medication label indicates that the stock solution contains 800 milligrams of dopamine in 250 milliliters. Calculate the milliliters per hour to be administered to meet the ordered rate. So let's start at the beginning here, where we're told that the IV infusion has to be given at a rate of 4 micrograms per kilogram per minute, and also that the patient's weight is 70 kilograms. These are our two given values. So our givens are 4 micrograms per kilogram per minute and 70 kilograms. Right away, we choose to multiply these two numbers. We do that because we know that this is a weight-based rate and we know the weight. So when you multiply by kilograms, it's going to actually cancel out the kilograms here and here. And when you multiply 4 times 70, you're going to get 280. And our unit that's left is micrograms per minute. So we always multiply by the weight as our first step for these so that it's not such a complicated unit. So now that is our given, and we are looking to find the amount in milliliters per hour. So we're looking for the number of milliliters per hour. Now, we are given the rate now in micrograms per minute. So we need to turn micrograms into milliliters and minutes into hours. Now, they did give us some information about this. We are told that there's 800 milligrams in 250 milliliters. So that is one of our conversions. So we can write 800 milligrams is equal to 250 milliliters. But remember, our conversion rate, our unit and our given is micrograms. So we also have to know how to convert from micrograms to milligrams, since our conversion rate has milligrams in it. So this is where we say that 1,000 micrograms is equal to 1 milligram. We're almost there. We do have one other conversion we want to consider, because our given is in terms of minutes, but we are looking for hours. So it's also important to note that there are 60 minutes in 1 hour. So we have 3 conversions we are going to do. So we start by putting our given into the first spot. So that's the 280 micrograms in 1 minute. Then we're going to start using those conversions. Now, the first conversion on our list is milligrams to milliliters, but we don't have milligrams or milliliters yet. So we're going to actually skip it and go down to the second conversion in our list first, which says that there's 1,000 micrograms in 1 milligram. Now, because our given already has micrograms in the top, we are going to write our conversion rate with micrograms in the denominator, which means milligrams goes on the top. So we have 1,000 micrograms for 1 milligram. We see micrograms do cancel. Now we're going to be able to use that first conversion we wrote down from the problem, because we have milligrams in our dimensional analysis. Since milligrams is on the top, we will put milligrams for our next conversion in the denominator on the bottom, and we'll put the milliliters on top. Remember that said 800 milligrams is equal to 250 milliliters. Our milligrams cancel, and so now we have milliliters per minute left for our units. We do want milliliters per hour, so we are going to use one more conversion rate, and that's going to be our 60 minutes is equal to 1 hour. Now, minutes are currently on the bottom of the chart, so when we do our conversion, we'll put minutes on the top and hours on the bottom. 60 minutes and 1 hour. Minutes here cancels with minutes here, and we're left with only milliliters per hour, which does match what we were going for based off of what we said in our unknowns. So now we're going to multiply across the top. 280 times 1 times 250 times 60 comes out to be 4,200,000, a really big number, but that's okay. And then we put that over, we're going to multiply out the denominator as well. 1 times 1,000 times 800 times 1 comes out to be 800,000. When we divide those, we're going to get 5.25. And remember, our final unit is milliliters per hour.